All right, so I want to talk to you about network analysis in journalism school. So I teach the double master's in computer science and journalism, but I'm also involved with a number of reporting projects. And so this work is really influenced by my time in the trenches, my battles with trying to get this technique to work. And to that effect, this is sort of the frame for this talk. I think of data science and journalism work as sort of appearing on these two axes. So when I tell computer scientists that I work in journalism, normally I get a response something like, oh, there's this great paper on event detection in news archives. That's not what I do. I work on the right side of this diagram in the production of journalism. And the other axis is what I call the research to reporting gap. It has proven extraordinarily hard to get advanced techniques from natural language processing and machine learning to work in journalism. This paper is a little bit about why and some of the challenges. A lot of what I'm going to talk about is in the upper right quadrant, right? So this is what journalists are actually doing, and I think that's key to closing this gap. So network analysis, what does this phrase mean? To a computer scientist, it probably means something graph theoretic, right? You might be computing centrality with some metrics, you might be finding clusters, all the way up to much more complicated stuff. This is from a paper that was here a few years ago, the bottom, where they're trying to find connected cliques of entities and saying that this represents a story. So automatic story finding stuff. But to see what people are actually doing, we have to go look at some case studies, right? Let's look at some published stories. So there are a few of these in the paper. Here's one of them. This is a story about how the Seattle art world works. So the nodes are artists and gallery owners and museum curators. And the data came from interviews. A journalist actually went out and interviewed all of these people and then transcribed who they were connected to professionally into a database. And they tried using degree centrality to color the nodes, but found that it didn't really produce anything interesting, right? So what does interesting mean when we're trying to build algorithms for network analysis? Instead, they colored them by their job, whether they worked for a gallery or so forth. And the finished story contained an interactive visualization. Stories in journalism that use network analysis don't always contain published visualizations. Here's an example. This was a story by the Tampa Bay Times on car thefts. It's kids stealing cars and joyriding. And the primary source for this was thousands of pages of police records. So the first step was they had to scrape all that information and enter it in a database. And then they focused on the largest connected component, on the theory that these kids run in groups, right? They know each other, and used centrality to order how they investigated people. So it takes a long time to investigate someone. You have to pay for background documents. They wanted to focus on only the most interesting people. So actually the network structure directed the reporting, even though this graph never appeared in the finished story. And you can sort of expand this out, and I expanded it out to 34 cases, which I got by posting on data journalism mailing lists and going through the investigative reporters and editors training archives. So there's probably, 400 or 500 stories that have now used network analysis. This is nowhere near a random sample of it, but it's a sample of the things that journalists like to talk about. And I coded them for how they use networks, where they got the data, what they did with it, how they analyzed it. Did they publish a visualization? Did they have to scrape it? Did they do some sort of algorithmic analysis on the network? And this is what the results look like. Publishing a visualization was very common. That's about 3/4 of the stories. Interestingly, about half of the stories created visualizations that they did not publish. And these visualizations turn out to be the primary analysis technique. Algorithmic analysis is not widely used in journalism. So why not? I think there's a few different reasons for this. One of them is that the networks that journalists use especially when you start to get into things like database fusion, are not homogeneous nodes, right? You have many different types of nodes and edges. You might have addresses, you might have people, you might have companies. This violates a fundamental assumption of almost all sort of classic network analysis research. We have some other assumptions violated as well. First of all, we don't normally have all of the data that we want. As we'll talk about in a second, it's often very difficult or expensive to get the data, which means that you often build out the network as you report the story, which means that you often are intimately familiar with the data that is already in there, which means that the network analysis algorithm doesn't tell you anything you don't already know. And finally, there's this issue of context. As Nick touched on, most of the information you need to interpret the network is not in the network. The real world is far richer than the formalism, and this is exactly what the reporter is tasked with knowing. So instead, what we get is visualization as the primary technique, where the reporter is using the network as a sort of memory aid or sort of conceptual map of the story. So moving now from what reporters have been doing to what they might be able to do. The Panama Papers, which we'll hear more about today, are an example of the state of the art, sort of where this is going. And in particular, there's a lot of excitement and a lot of experimentation right now with graph databases. And this is the theory, right? We take all of these data sets, we fuse them together, then we can run queries on them, we can do interactive visualizations. I call this the one graph to rule them all approach. And the idea is that this is really going to solve investigative journalism on these very complicated stories. So there's some problems with this. For one thing, you need to have the data in structured form. And actually, the bulk of the Panama Papers was documents which have never had entities extracted. So all of the graph stuff that was done on the Panama Papers came from the structured information. That's because entity recognition is hard. If you read the NLP literature, you sort of get the idea that like entity recognition is kind of a solved problem and it's almost boring for researchers. Not so in practice. For starters, the documents that journalists work with are extremely messy. You know, they have holes punched through them, right? And even if you start with clean text data, even commercial entity recognition systems only have a recall of about 70%. For investigative journalism, you really want to favor recall over precision because missing something is much worse than having noise, right? The journalist is going through huge amounts of data anyway. So it's just not solved, and relation extraction is even worse. Event detection is even worse than that. And then record linkage. If you join n databases, you might have n copies of each record that you have to unify. So this is actually from that Panama Papers slide. You have completely unlinked records because they have a slightly different address. And then on the bottom there, you have what I call soft record linkage, right? You keep the original node, but you have an algorithm try to say, oh, these things they look like they're the same. And that's what you want. You don't want the computer to make the final decision about which entities are the same because you can't publish a story about a criminal act and say, well, the model says there's an 84% chance that these two people are the same, so we're going to say that a crime has been committed based on that, and we're going to publish your name, right? So all of these record linkages have to be reviewed by a human before they can be used in published work. So this is sort of what the reality of graph database usage looks like in journalism. The first stumbling block is you never have the complete data set, or it might be very expensive or unwieldy, or you might have to order documents to get it. You may even have to pay per document to load this data. In many jurisdictions, it's like $10 to get a public record, right? So you're iteratively building out this data. You don't get to just dump it in the database. Then you have the record linkage problem, and then graph queries. Not that helpful. Hard to use, and it's not clear to me that there are actually that many reporting problems that can be expressed as a graph query. Even just find path between two nodes, as far as I could tell, was not used in the Panama Papers. So instead, I think we should think about these networks as narratives. So here's a map from work at Columbia Journalism School on Trump's business network, and this was hand-built, right, to try to help reporters orient what they're learning. So I want to emphasize this hand-built nature, right? When you do a graph query, you get this explosion of nodes. The more data you have, the worse this gets. What you really want is to be able to add nodes that appear in the database one at a time, which is what the Linkage search interface on the right does. Even things like finding shortest path, which you'd think would be a very easy query, they tend to go through large nodes like country or something. Even basic graph queries fail. So instead, what I wish we had was a system that looks something like this. We build up this huge graph database, yes, but that's not the database that the journalists actually look at. We extract entities from documents. I'm not even going to talk about relations, just these two names appear in the same documents and the reporter can figure out. We can load structured data. And then we have this mapping step where we do this soft record linkage to produce clusters of entities that look the same that the reporter can then add one by one into these maps. And there can be more than one map per story. On the Panama Papers, there were about 400 reporters, and about 3,200 network maps were made in Linkage. So that's about 8 per reporter, right? And so if you take nothing away from this talk, the sort of concept that I'm trying to get across is there is a deep conceptual distinction between the data that is in the database and the visualizations that the reporters are using to actually report the story. It's not about the algorithms, it's about the actual workflow that the journalists are using. Thank you.